Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's get started with lesson 4.1.4. This is a lesson where we finally introduce our formula for linear equations with two variables. You'll be using this a lot. This is y equals mx plus b, and this is referred to as the, well, should I do it in red? The slope intercept form of a linear equation, slope intercept form, y equals mx plus b. And each one of these variables has a particular meaning within the context of the problem that you are solving. Although two of them are truly considered your variables, and two of them are what we would call our parameters. So let's get started. The variables in this, let me actually write it again, y equals mx plus b. The variables are your x and your y. Remember, these variables have to do with your x, y tables and your x, y coordinates that you'll be plugging in onto a graph. The x is your independent variable and your y is your dependent variable. So think of our tile figures. X is the number of your tile figure, and y represents how many tiles there are in each one of those tile figures. So the independent variable, I like to tell students, is the one that you have control over. Like, you can choose any tile figure that you want, and then the y depends. How many tiles do you have? Well, it depends on what your value for x is, what figure number you're talking about. Now, sometimes that analogy doesn't work. Either one of them could be switched, the independent or the dependent variable, but the x is always going to be the independent variable, the generic x, in our rules, and the y will always be the dependent variable. Okay, and then we've got the parameters. The parameters are the m and the b. Remember from lesson 4.1.3, the growth factor, or the growth rate, is the number that's being multiplied times x. That is your m. So this m, when we write a rule, is actually going to be a number. That's going to be the growth factor. And the b is your starting point, or what we refer to as the y-intercept on the graph. So when we're talking about tile figures, the b is however many tiles are in the zero figure, because that's what you're starting with. When x is equal to 0, it doesn't matter what your growth rate is, y is always going to be equal to this number here, okay? So that's where you're starting. And then m is your growth rate. How many tiles did it increase between each figure number, okay? So we're going to use this information now to move forward with our understanding of linear equations, growth rates, starting points, and how to solve problems by creating the appropriate rule. So in lessons 4.1.2 and 4.1.3, you investigated connections between tile patterns, XY tables, graphs, and rules. Today, you will use your observations about growth in figure 0 to write rules for linear patterns and to create new tile patterns for given rules. All right, so with your team or on your own, I guess I want you to brainstorm, list some of the equations that we've been working with the past two lessons. So go, if you've got everything written on those printouts, go grab those printouts. If you've got everything in your journal, then you should be able to look back at the last two lessons. There were 4 rules, if you don't include any that I made up on the spot just to illustrate something. What were those 4 rules? Pause and write down what those 4 rules are. Okay, I'll go ahead and pause too. All right, you got them written in? Remember, 3 of the rules had the exact same growth rate, and a couple of the rules have the exact same y-intercept. So the rules were y equals 4x plus 2, y equals 4x plus 1, y equals 4x plus 3, and then the other one that had a different growth rate but a similar starting point, or y-intercept, was y equals 2x plus 3. So what do all these rules have in common? Go Go ahead and pause and see if you can identify what they have in common. And maybe not all of the rules will have something in common, but some of them will have something in common. So go ahead and list out what some of them have in common. And I guess there is something that all of them have in common. Go ahead and see if you can figure out what that is and jot down a few statements. All right, so if we were to answer the question, what do they all have in common? You could say, yeah, they all have an X and a Y variable, right? That's definitely something that they have in common. You could also say they all have an equal sign. Yeah, I suppose that's true. And the fact that you're adding something at the end, although you'll find out that sometimes your y-intercepts can be in the negative range. And so it would say, maybe 4x minus 3 instead of 4x plus 3. Or you could say 4x plus a negative 3 as well, but people typically don't do that. That's something that they have in common. And they also have a number that's being multiplied times x in every one of those situations. Okay. On top of the fact that 3 of them have the exact same growth rate, that would have been something that those 3 have in common, and 2 of them have the same y-intercept. But what do they all have in common? They all have x and y variables, and they all have something being multiplied times the x. All right, so understanding y equals mx plus b. We've kind of already talked about this. Rules for linear equations can all be written in the form y equals mx plus b. In y equals mx plus b, the x and the y are the variables, and the m and the b are what we call parameters. And parameters are the numbers that stay the same in the equation after they are chosen. So let's go back here. Remember, variables mean that they can change. So you can change the x and make it equal to 2, or you can make it equal to 3. And once you change the value for x for this particular rule, it changes the value of y. But the growth rate is always going to be the same for this particular situation, and so is the starting point. So the parameters never change, but the variables will, which is why we call them variable, because they can change. So what does M tell you about the pattern? What is the M for? What did we call that? Well, that is the growth rate, correct? That tells you how much the pattern is growing by between each figure number. And what was the B telling us in the pattern? The B was the y-intercept, but it was also telling you where you were starting. Okay, so the starting point of the pattern. Like the fact that I'm typing things out now instead of writing them. I thought that was easier for you to read probably. All right, so Alicia claims she can find the equation of a line by its graph without using a table. How on earth is this possible? Is she magic? What? Discuss the idea with your team and then try to find the equation of the line right without first making a table. Be ready to share with the class how you found your rule. All right, so I'll just give you a little bit of a starter point here. Remember, the growth rate can be seen in the graph. You're looking at the growth triangle. And the y-intercept, oops, I didn't want it to be this. Okay, that's fine. The y-intercept can also be seen on the graph. That is like a starting point. So where is the starting point here? That would be the y-intercept, correct? And where do you see the growth? You see the growth rate happening here. And you could see it there, or you could also see it here, or you could see it between any 2 points, okay? So go ahead and take some time to see if you can figure out what the growth rate is and what y-intercept is, and then what the rule is. Okay, so you might have said something like this. You can see both the starting point and the growth rate of the pattern, so you can identify the equation of the line. So let's go ahead and let's write out y equals mx plus b. And the m is the growth rate. That's going to be how much y changes between any 2 points, written as a ratio over how much x changes. And then the b is your y-intercept, where x is equal to 0. What is y going to be equal to? Y, in this particular case, is going to be your y-intercept, which is your b. So let's start with that. What is b equal to? B, the y-intercept is right here, where x is equal to 0, y is equal to 1. That means our y-intercept is going to be a 1. And what does the growth rate look like? It's go from here to here, how much does x increase? It increases by 1. And to go from here to here, how much does y increase? 1, 2, 3 units. It increases by 3. So the growth rate here is going to be 3. So those are our parameters. And so the rule for this situation is y equals 3x plus 1. So let's prove it right here. Let's make x equal to 2. If x is equal to 2, then this becomes 3 times 2 plus 1 is going to give us our y value. What is 3 times 2? That is 6. And what is 6 plus 1? That is 7. So this point right here is where x is equal to 2, y is equal to 7. And that is absolutely the point on the graph. So we just verified that our rule that we created from looking at the graph does indeed give us the ordered pairs that make up the graph. Okay, so notice that the y values are increasing by 3 every time, and the x values are increasing by 1. Okay, so just by looking at any graph, you are able to then determine the growth rate and the y-intercept, which is your starting point, and then take those pieces of information and create the rule. And this is bothering me a little bit. I want to make that a little bit cleaner. Okay, there we go. All right, so table to rule. Alicia wonders if she can use the idea of the m and the b to find the equation of the line from its table. So let's go ahead and let's follow this growth pattern. So this is saying that y increases by 5 every time that x increases by 1. So go ahead and fill in that data into your table and pause it. And then when you unpause, see if yours matches mine. All right, so if the starting point is at -2, then every time x increases by 1, y increases by 5. That means that the next point has to be 1, 3, right? Because 3 is 5 more than -2. And then the point after that would have to be an 8. And then the one after that would have to be a 13. And so when you continue with that pattern, you are able to fill in the table knowing that each one of those y values increases by 5 every time. So what is the starting point and what is the growth rate? In this particular situation, we've got m, which is equal to 5, that's the growth rate, and b, which is equal to -2. So our rule for this situation has to be y is equal to our growth rate times x, and you can say plus a -2 or just say -2. That would be the rule for this particular table. Let's use the same idea on these two tables. Okay? So in this case, they're not telling you what the growth rate is. You have to determine what the growth rate is on your own. So for each one of these situations, identify what is the growth rate, what is the y-intercept, so therefore, what is the rule, okay? And we'll do this twice. I'm gonna go ahead and clone this. I'll change the color so they don't bleed into each other. Very nice. All right, go ahead and pause, and when you come back, let's see if you've got the exact same growth rate, y-intercept, and rule that I have for these two tables. Okay, starting with table number 1. We see how it's growing here. To go from here to here, from here to here, from here to here. What is it increasing by? It looks to be increasing by 2 every single time x increases by 1. So that means that our rule has to have a growth rate of 2, and the y-intercept, what's going on here? There you are. The y-intercept is when x is equal to 0, so that has to be 5. So our rule ends up being for y equals mx plus b, y is equal to 2x plus 5. And now let's test it to make sure that works. Let's take this point right here. When x is equal to 4, 2 times 4 is 8, and 8 plus 5 is 13. Let's check it again. When x gets multiplied times 2, that's 2 times 5 is 10, and 10 plus 5 is 15. That confirms in both of these two ordered pairs that this rule actually works for those two, so it'll work for all of them. Okay, now let's take a look at this one. In this case, it looks like the growth rate is more of a rate of decline. It's going down by 3 every single time. So we'll call that -3. And the y-intercept is at 7. The computer's getting a little glitchy on me here, so pardon that. So that means that the rule has to be y equals -3x plus 7. So let's test that rule out on 3. -3 times 3 is -9, and -9 plus 7 is -2. Let's try it with this one right here. -3 times 1 is -3, plus 7 is 4. Absolutely. So it works for this one. It worked for this one. It's going to work for all of them. So write a summary statement explaining how you used your knowledge about M and B to quickly write the rule. Go ahead and pause. Formulate your thoughts. It's really important for you to put your thoughts into words so that this can sink in at a deeper level. Okay? Go ahead and pause it and unpause when you're ready. I'm not going to bother pausing myself. I'm just going to give the reveal. The growth rate M is the amount that Y changes for every time X changes by 1. The starting point, which is your B, also referred to as your y-intercept, is the value of Y when X is equal to 0. All right, so now we're going to take a rule, which is this one, and we're going to build a tile pattern for this rule. We use the same one that we used in lesson 4.1.2. Just create your own design, but remember, you want it to grow according to a pattern, not just randomly. So what do we know about this rule? We know that the growth rate, M, is equal to 4. That means that every tile pattern is going to have 4 more than the previous. And where does it start? The B is equal to 3. So figure 0 has to have 3 tiles. So your task is to create some kind of a tile figure for figure 0, 1, 2, and 3, where you start off with 3, and then everyone gets 4 bigger. Okay, go ahead and pause. I'm going to build one as well. You just draw this into your journal. Okay. Okay. Alrighty, this is what mine looks like. We know that the y-intercept, or the starting point, was 3, so we need 3 tiles, and I just decided to make a little L shape. And since the growth rate was growing by 4 every single time, I decided to add 2 to the top and 2 to the side. And so let's go ahead and count to verify that this rule actually matches these tile figures. This has 3. This has 1, 2, 3, 4, 5, 6, 7, and 4 times 1 plus 3 is 7. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 4 times 2 is 8, plus 3 is 11, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is it growing by 4 every single time? Yes, it is. 3 times 4 is 12, plus 3 is 15. So this is an adequate, accurate tile pattern for this particular rule. Now, this one is a little bit different. This is asking us to decrease by 2 tiles. So we're going to start. It says figure 2 of the pattern has 8 tiles. So what we're going to do is we're going to start with figure 2 that has 8 tiles, and we want it to decrease by 2 tiles. And so we're going to have to think about that pattern of decline and create a tile pattern that matches that. So what would, I guess we don't even know what the y-intercept is going to be yet. We're going to create the rule at the end. So we don't even know what the 0 figure is yet. So go ahead, see if you can start with a figure 2 that has 8 tiles, create any pattern, and make sure that your 3 has 2 less, right? Because as X increases, as the figure number increases, the number of tiles goes down. So if figure 2 has 8, then that means this one must have 6. So how many would be in the first one? That would have to be 10. And how many would be in the 0 figure? That would have to be 12. So at this point, I know what the rule is, because it's going to decrease by 2 tiles as its growth rate. That'll be -2 times X. And where did we start off? We start off at 12. Does that work for the figure 2 having 8 tiles? Negative 2 times 2 is negative 4, and negative 4 plus 12 is equal to positive 8. Great. Okay, go ahead and build your tile pattern, and I'm going to do the same. All right, so this is what I decided to do. I kept it simple. I just had 2 rows of tiles, and as it decreased, so this would be figure 2 with the 8, so it goes down by 2 every single time, so I just took 2 off of the right for figure 3, but then when you're going in the other direction, you've got to add it. So if you're starting here with 12, this one would have 10, this one is going to have 8, then this one would have 6, then figure 4 would have 4, and so on and so forth, until eventually I guess you can go any further because we're not going to create negative tiles here. So does it have a growth rate of negative 2? Yes, it does. It goes down by 2 every single time. Figure 8, this would be like 2, 8. This one here would be like 1, 10. And this one would be your y-intercept of 0, 12. And this one would be 3, 6. All right, is that about it? That is about it. All right, so we are starting to develop a deeper understanding of the connections between each one of these representations. And what we're eventually going to do is we're going to go away from the tile figures and start coming up with word problems to help us understand. No, not help us understand. What are we going to? We're going to have word problems that we're going to use these strategies to help us understand how to attack the word problem and how to solve the problem. Make predictions, make estimations, and then actually use these strategies of finding growth rates and starting points and our 2 variables to solve the problems. I think I rambled on a little bit. You get the idea. Let's just move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood.